In this episode of Scaling Postgres, we talk about Sysadmin concerns, the power of indexing, PgBouncer monitoring, and PgPrewarm. I'm Preston Jameson, and this is Scaling Postgres, episode 32. All right, I hope you're having a great week. Our first piece of content is actually an announcement. Actually, the first two are announcements. So Postgres 11 Beta 4 has been released, and it mentions some of the changes that have occurred since Beta 3. It seems like most of them are related to just general bug fixes from different features. However, just to call out the JIT compilation, which I've mentioned in previous episodes, it says, quote, JIT compilation is disabled by default. To enable JIT compilation, you must set JIT equals on in your configuration file or in a session. So it looks like you don't have to do it at build time, which I believe that was something referenced in previous information I had seen about JIT compilation. So it looks like something you could trigger on and then potentially do a reload of the whole server config or do it within a particular session. So definitely something interesting to check out. But of course, you can consult the link to review all the changes since Beta 3. The next announcement is that PostGIS 2.5.0 has been released, and it mentions although this release will work for PostgreSQL 9.4 and above, to take full advantage of what it offers, you should be running PostgreSQL 11 Beta 4 and up. So if you use PostGIS, looks like it's ready for working with Postgres 11. The next article is running a database on EC2, your clock could be slowing you down. And this is from the heapanalytics.com blog. Now, this is an interesting case where they saw a significant portion of CPU time being taken up checking the system clock. And this is in part they discovered due to the virtualization that AWS on EC2 was using. Now, ultimately, it looks like at the very end of this post, they're talking about AWS EC2 moving to a KVM virtualization that kind of bypasses this problem. However, this post is interesting because it gives you insight into how an organization is scaling a petabyte scale PostgreSQL database or series of databases. So any content that's produced by the Heap Analytics blog, I generally want to be familiar with because they're really scaling PostgreSQL. So some of the insights they talk about is that they tend to store their data in i3 instances. So they're not using the elastic block storage or EBS of AWS, but they're actually using the NVMe storage that's on each instance due to its significantly higher I/O capabilities. Now, of course, there are downsides to that because to my understanding, if this instance has to be restarted, that storage is ephemeral and it just vanishes. So I'm not sure you would want permanent data storage being sitting there. But it does give you really high I/O if you need to use it for particular use cases. And of course, through this blog post, they have links to other articles that the Heap Analytics blog has done about how they're scaling Postgres. And all of them are, I would say, pretty much must-reads if you're looking to scale Postgres. So again, this particular issue, I think, is going away with time, where the clock has taken a lot of resources and how they kind of got around it. And if you suspect that type of problem, you should definitely consult this post. But really, it's an opportunity to learn more about how one is dealing with a petabyte scale PostgreSQL database. Now, related to that, there was a post on Hacker News that you also might want to consider, and it's a database engineer at Heap Analytics discussing why they use EC2 as opposed to using RDS. And they say they do use RDS, but they use Postgres on EC2 for their primary data store. And the reason why he goes into is the cost. It's much cheaper to not use the RDS platform. They're able to get a higher performance, again, because they're using the i3s and the NVMe performance they get compared with the elastic block storage in AWS. The flexibility of configuration. And he mentions they're actually using ZFS, which enables them to compress their data twofold. And also the ability to do some introspection. So again, another post that gives you insight into how someone is running a petabyte scale PostgreSQL set of database clusters, essentially. So I would say both of these are essentially must-reads if you're looking to scale Postgres. The next post is Power of Indexing in PostgreSQL. And this is on the secondquadrant.com blog. And essentially, this is a YouTube video. I believe it's about 50 or 55 minutes. And this is an excellent video that has actually helped explain better than I've found in other places why Postgres does some of what it does. So he goes into depth into indexes, how it works with the heap, as well as B-tree indexes and why it does certain things. And it basically takes some of the best practices that you hear people say, and he actually explains kind of why they're best practices and how it works internally and why it works better doing certain things. So again, if you're a developer or a DBA, knowing how to use indexing enables you to get the most performance out of your database. So if you're looking to scale, I highly suggest watching this YouTube video, as it was definitely informative for me on a lot of different levels. The next post is Use Red in Real-World PgBouncer Monitoring. And this is from the okmeter.io blog. And in it, he's covering two monitoring concepts. One is Use, which is an acronym for Utilization, Saturation, and Errors. And then another called Red, which is Rate, Errors, and Duration. And essentially using these frameworks to look at monitoring PgBouncer and how okmeter kind of does that. Now, in my experience, PgBouncer documentation is okay, but it's relatively hard to get in-depth articles on it. Pretty much if there's any PgBouncer article I find, I'm going to put up as something to consult. And this goes into a little bit the internals, of course, of how PgBouncer works, and then looks at some of the methods you could use to monitor it. And he talks a little bit about what okmeter does in terms of monitoring it. So if you use PgBouncer or are considering using it in the future, this is definitely a blog post I suggest checking out. The next article is Autoprewarm, a new functionality in PgPrewarm. And this is from the postgresrocks.enterprisedb.com site. Now this covers PgPrewarm, which there was a new enhancement in PostgreSQL 11. And this new feature automatically warms the shared buffers with the same pages held before the last server restart. So it basically pre-warms your cache and keeps it up to date. And it shows you the command to use to set it up. And basically it creates a background process that periodically record information about the pages in the shared buffers to basically keep it cached up in the case of a restart. And he showed an example here where he runs this query after setting up pre-warm immediately after restart, and he gets on the buffers a shared hit for the aggregate and the sequential scan. Whereas when he didn't pre-warm it, it had to do a read. And then goes into some additional tests that were done that show with pre-warm on, transactions per second goes up immediately after a restart, whereas if you don't, you have a longer ramp-up time to achieve the same state. So if you think this could be of advantage, or you want to take advantage of it in Postgres 11, definitely a blog post to check out. The next post is on rocks and sand, and this is from the secondquadrant.com blog. And they're talking about column order basically in tables, and that Postgres actually creates padding based upon what columns are next to each other. And when you have your column types distributed in a random order in the table, there's a chance that a lot of padding will be introduced, which will cause the table to be larger than actually the data it contains. And that if you're able to plan out what your column order is based upon the data types, you can actually achieve a space savings in the data being stored. Now they have a comment here because it says, quote, "It's not uncommon for column orders to be dictated by a hurried dev simply jotting down attributes, or an ORM that generates output from an arbitrarily hashed key position." Now, in my experience, in terms of doing development, it's just new features need to be supported and new columns get added, and that kind of causes havoc with any kind of ordering. You can establish an ordering, but in the process development, oh, you need feature X, you need feature Y, you need feature Z. It's hard to maintain any kind of column order in that case. So some of the advice in this post is hard to follow if you have more of a transactional load database that new features are being added to on a consistent basis. However, if you have a more analytical database and essentially your data model doesn't change that significantly over time, you could get some space savings by following the advice included in this post to order your columns based upon data types as they suggest here. Basically, doing things like having big ints first, timestamps, then ints, smaller ints, booleans, and then following up at the end with numerics and or text fields. And in this example that they were looking at, they saw a 21% space savings. So again, with a rapidly changing application, I think this will be kind of hard to do, but if you're working with a more analytical database where you have more flexibility with a column order, or at least keeping it consistent, following this advice could potentially get you some space savings. The next post is Fun with SQL, Unions and Postgres. And this is from the citusdata.com blog. And it's a relatively simple and short post. Again, their SQL series is like that. It covers union and union all. So basically, union enables you to merge two tables together, and union automatically does a distinct between the rows that are selected, whereas union all shows all rows not distinct. So if you think you might have some use cases that could benefit from a union, definitely a blog post to check out. The next post is Understanding Check Constraints in PostgreSQL. And basically, this goes over check constraints at the column and the table level and how to set them up. And in terms of scaling, it shows you how you can actually add constraints and have them not be valid as a way to add them gracefully to a particular table. So if you're wanting to learn more about check constraints, definitely a blog post to check out. That does it for this episode of Scaling Postgres. You can get links to all the content mentioned in the show notes. Be sure to head over to scalingpostgres.com where you can sign up to receive weekly notifications of each episode, or you can subscribe via YouTube or iTunes. Thanks.